So next one we have what is called as all day efficiency. So this is a more practical term we relate to the efficiency of transformers. The transformer is running for the entire day, correct? So you assume that you are near your street end, you have a transformer. It is running 24 bar 7 bar 365. It has no rest. Only monthly once they will give a maintenance shutdown and they will shut down power in your area and say that from 9 to 5 power will not be there. They will clean the transformer and do everything. So the instead of finding out the above expression called efficiency, the below that this term all day efficiency or commercial efficiency is going to have more significance. Okay, so the all day efficiency is also called as commercial. Sorry, the previous efficiency is called as commercial efficiency, but what we are going to see now is called as all day efficiency. All day efficiency means it is because you know that the load of the secondary is varying during the day and night. So if that is the case, see under constant load, the above efficiency will be helpful. But when the load is varying, the daytime nobody will be using the AC. The night time suddenly at 8 o'clock, everybody will be switching on the AC. So load current is increasing at the night time, right? So when the load is varying in the daytime and night time, this all day efficiency is going to give a significant explanation. The more the rather than the previous efficiency called as commercial efficiency. The previous eta it is called as commercial efficiency. Commercial means just all the in the transformer, if you buy any transformer, this commercial efficiency value will be printed. But all day efficiency will clearly give you an idea of the transformer is operating throughout the day and night, what with different loading conditions. In that case, what is the efficiency of the transformer? See, see, assume that there is no load in the daytime. The daytime there is no load. No load means your core loss will be existing or the iron loss will be existing. Sorry, the constant loss will be existing. But when the transformer is loaded, then your copper loss will also come into picture. Okay, so we will not clearly know when you are going to switch on your AC. Sometimes, if the during summer season, 7 p.m. itself, some people will switch on their AC. But some people will switch on at 8, some at 9, some at 10. So the load is keeping on varying, right? So daytime, assuming that the climate is relatively cool, people don't switch on their AC. The only core loss you will have, that core loss is going to be constant throughout the daytime. But when the night time starts, the transformer is going to be loaded. So for that, such kind of transformers, the different types of load, all day efficiency is going to be a significant number for measuring the efficiency of your transformer. So see the expression for all day efficiency. So all day efficiency eta all day equal to output energy in 24 hours divided by total input energy. And when you find the efficiency in day for a particular time, we will not use power, we will use energy. Because power equal to energy by time, energy equal to power into time. So power, you see, I'm multiplying power by time. Output energy in 24 hours. See the unit kilowatt hour. So kilowatt is power, hour is time. So power into time becomes energy. So output energy in 24 hours divided by total input energy in kilowatt hour. So previous efficiency, it is output power by input power. But here in all day efficiency, it is output energy by input energy. Please understand the difference. Why we are converting into energy? Because it is varying for every 24 hours. We are assuming if the transformer is operating from 6 a.m. today morning to next day 6 a.m., what is the all day efficiency of the transformer? But the previous expression for efficiency, commercial efficiency, it is a generalized number. It is going to be a constant number, which will clearly say this will be the efficiency of transformer for a given at all point of time. The commercial efficiency will be constant value, but this all day efficiency will be varying depending on your load. Any doubts you have? One difference I say, commercial efficiency is ratio of power, all day efficiency is ratio of energy. And energy, you know, energy is power into time. So time will come into picture. So this in the expression you see 24 hours. So we are going to measure for one full day what is the output energy, what is the total input energy you are going to give. That ratio is going to be the all day efficiency of your transformer. Maybe if
Sir,
we do,
doubt, sir.
yeah, yes.
Sir, not in topic, you said that the iron loss will be constant and the copper loss will only increase when load is present, no, sir? Why so?
Yes. See, when load more the load you're adding, that's what I say. More the number of ACs you turn on, more current is required for running your ACs, right? More
Yes,
current
sir.
means like a copper loss is given by I square into R, right? So more current means more copper loss.
But why iron loss is constant, sir? Then more current will be needed, no, sir? So,
See, core iron loss or core loss, it was going to have only two things. Hysteresis and eddy current loss, right? So those two are going to be almost constant for throughout the transformer. See, why do we say constant means by measurement they found that the variation in that two loss is not going to be that large compared to your copper loss. That is the reason why we consider them to be constant. They are also varying slightly, but the variation is not that much big.
okay, sir.
Variation will be there. When the current is going to change, everything will change. But how copper loss is going to change, that much fast your core loss or that iron loss is not going to change. So that is the reason why we consider that core loss will be constant throughout the day, and on copper loss will be occurring only when you're going to load your transformer with the appliances.